a data scientist at Biterna. He joined Biterna team in 2020, and now he works on all parts of the machine learning process, from building architectural pipelines to fine-tuning models to visualizing the business insights gained for them. And I will now use the opportunity to say a few words about the company itself, but we're going to see the video afterwards. So Biterna is one of the leading providers of ERP, BI, CRM, and HRM solutions in Europe, offering full-service business software and business processes management solutions. Their customers include global corporations, as well as innovative SMEs that are looking to deploy modern business software solutions in order to gain and maintain a strategic competitive edge. Over 1,000 employees in Europe support more than 1,600,000, oh my god, which number did I just say? 1,650 successful, mainly international manufacturing companies and commercial enterprises. I'm already tired, I bet how you must be feeling. Okay, and now to just give the word to our Nino. Everything about Nino that you need to know, he will probably say for himself as well. We will take a look at 2 short videos, and then it's your turn, I promise. Enjoy the videos, and then Nino.
In a retail company and oversees ordering goods for 50 suppliers on a daily basis. They request daily reports on historical sales from their IT department. The next step will be optimizing truck fillings with respect to information such as packages, sizes, lead time, and more. This whole manual process often results in many problems.
There are 2 components which make our solution highly precise in terms of forecasting sales in various industries. First component monitors and evaluates daily which machine learning algorithm best fits each item, and the second component constantly learns by comparing its own recommendations with actual sales that happened in the market.
Our platform can help precisely forecast up to 97% of the inventory and help place fully controlled orders in time, so that you can avoid warehouse jams and still keep your items on the shelves for customers. This high forecasting precision allows us to lower stock levels on some categories for up to 65%, while completely avoiding out-of-stock situations. Our platform integrates historical data, external non-transactional data, and all relevant constraints, without a need for any installation on your premises. The secret lies in the fact that our solution picks the best suiting algorithm for each individual stock-keeping unit, and then creates a demand forecast. The forecast is next run through numerous vendor-specific constraints, including a cargo optimization module, which results in an optimal proposal for an upcoming order. Fully optimized order proposals are integrated seamlessly into your ERP solution using modern APIs.
I want every company to take it through.
Had subtitles. One applause to Nino.
Hi, can you hear me? Okay, great. I'm not on mute, but I don't see a presentation here. Okay, let's start it. Okay, I'm Nino. I'm a data scientist from Biterna, as I was introduced before. And today I'm going to present you the manufacturing optimization and planning using machine learning platforms. So this is the solution you saw previously, but this is the manufacturing part. It's a bit different. The previous part was more oriented on distribution systems, so it's distribution companies. So I'll try to be short and I'll try to be simple as possible. So we'll first go through introduction on the problem. Then we'll introduce the machine learning platform, what it actually is. And then we'll go through some examples, and in the end, go through benefits and conclusions. So let's start with the problem. So let's say we are one factory. We have to produce something. We are producing something. And the first thing we have to do, we have to get ingredients or raw materials to produce our products. So first we place an order to our vendors where we're buying the raw materials from, and then they send us those raw materials to our warehouse. And after we have items on the warehouse, we have to use them to produce the final products. So we have to plan next. We have to plan on which machine we're going to produce which final product to have it on stock. And when we are done with that, we have a full stock of items. And now, when we have a full stock of items, customer comes in. Customer comes in, customer says and schedules a purchase order from their side to order 50 of that, 60 of that, and 70 of that, and then we send all those items to a customer. So this is like a high overview of some manufacturing company. So what are the points where AI can help us? So point one, demand forecasting. So we can forecast how much are going to customers need from us. So this is simple forecasting, simple to say this is a predictive analytics part. Forecasting the demand that customers will buy. The next point is the optimization of planning. So when we know what we have to produce, we can optimize the planning on which machine we're going to do something. And this is the point two, this is the prescriptive part, when to produce something. And the third point is scheduling purchase orders. When we know when producing something, we know how much the raw ingredients we're going to need to produce something, and with that we can make another prescriptive analytics to set up purchase orders from our vendors. So here, machine learning platform comes to rescue. This is the pipeline. I will go through a pipeline of a machine learning platform, and everything starts, as always, with the data. That's why we're here, Data Science Conference. It starts with the data. The first thing we need sales data. How much we sold to our customers, so those historical sales. Also, we need the information about the current stock we have on each item, on each product. And then we have to have some information on the production. So, what machines do we have? Which products are made on which machine? What raw materials are used for each final product? And so on and so forth. And then we go into demand forecasting. In demand forecasting, we do a machine learning model per each product, each item we have to sell. And then, when we have those forecasts, we evaluate those forecasts, and we come back at scheduling work orders. Quantity definition means that we define how much we have to produce at our manufacturing company. And then we can output that in some BI tool, ClickSense, Power BI, or any other. And now we can do a little nifty thing. We add a plan to this pipeline. So those outputs, how much we have to produce, are the inputs to a planning module. Planning module takes those work orders, optimizes the plan using evolutionary algorithms, genetic algorithm, and then outputs how much we need to order also of the ingredients from our vendors. And we can also output that in BI application. So, okay, this was a bit of an overview of that, but let's get it more simple. Let's get it on Lego bricks. I personally loved Lego bricks when I was a kid, so this is how it works. We have parts, some parts of a minifigure, we place them together, and when we place together, we get a final product. This is a minifigure that we're selling then to a customer. So let's go to example how is that done within machine learning platform. So, as I said, it starts with forecasting the demand. First, data needs to be right. The data needs to be true, relevant. We need those historical demands from the history. We need some contextual information, outliers, promotional periods, and then we do forecasting. And this is the first minifigure we are building. Actually, this guy right here has very similar shirts like this one. I have to say that. And this is the first product we're building. This is really, really summerish kind of shirt, right? Summerish is. And it's really seasonal. You can see these are the sales over a period of time. These are the historical sales, and they're really seasonal. As you can see here, over the summer, the sales are much higher than during the winter. And our forecasting module, forecasting the demand, has to account for that. It has to forecast higher sales, of course, in the seasonal periods. And then the second minifigure we're building is this police officer that has hair on his head. This is a hairy police officer. And this police officer has some weird sails right here and right here. And those weird sails are outliers. So also our forecasting has to account for the outliers and not to forecast them into the future. And the third minifigure we're building in this example is a bald police officer. So this police officer doesn't have any hair on his head. And this police officer has some specific sales right here. This was a promotional period of this item. And also right here, we know that promotional period will happen once again. So we need to expect the higher sales in the promotional periods. So we're done now with part one. We forecasted the demand from a customer. And then we go into planning. The planning means that those three minifigures we build will be the final product. This is what we call them, F1, F2, and F3. And those minifigures are built from the ingredients and half products. So ages are half products. So this shirt with knife on is a half product. Then this police officer body is a half product. And then pants, heads, and hair is an ingredient. But also a half product can be separated into ingredients, into its own raw materials of police torso and pants. So overall, the three of our minifigures are built. So police officer with hair is built from police body, hair, and head, while this summer guy is built from head, torso, and pants, while the bald police officer is built from police body and head. And also our ingredient of police body is built from police torso and pants. And now let's plan them. Let's plan the production of these items. We know the demand, and now we have to plan. This is our planner. This is the machine 1 for the final products. This is the machine 2 for the final products. And this is the machine for half products. And these are all the ingredients we have and have products and their current stock at the beginning. So let's plan the production of F1, the hairy police officer. And with that, we lower the stock of H1, which is ingredient for it, hair, and one head. Then let's schedule a production of F3, a police officer without hair, so bald police officer, on the next machine. By doing that, we also lower the stock of police body. But now you can see here, we're below zero. We don't have enough to build here. And also, we need head, and again, we're below zero. So we need more. And also, we need to build also F2, the summer guy, who uses the quantities of H2, and also he needs heads. So we don't have enough heads for F3 and F4. So how are we going to fix that? The first thing we're going to do is produce H1. This is a half product. This is what we are producing inside our company. So by doing that, the quantity on the stock of H1 goes up when it's produced. But that's the problem. It goes up when it's produced. So we're still lacking it, because we still don't have enough to build F3 right away. And what we have to do is postpone the production of F3. And by doing that, the quantity of H1 is not fine. We have enough H1 for that. But also, by producing H1, we lower the quantity of E3, and now here we are also below zero. We don't have enough to build H1 and F2 again. And what we have to do now, those are the ingredients we're missing, the raw products. We have to order them from the vendor. This is now replacing a purchase order from the vendor. And by doing that, the quantity of E2 and E3 goes up. So we're done with E3, we have it enough. But we're still missing E2. We don't have it enough to produce F3 right here and F2 right here. So what we're going to do next, we again have to postpone the production of F3 to help all the products that we need. And voila, we have enough H1, H2, E1, E2, E3, and E4. We have all the ingredients needed, and we can schedule a global order how our plan is going to be. So look at them. We build them. We build them. Oh, sorry. We build those minifigures. Actually, you can add. To share what we build. We build a simple example of a minifigure. You also have one. So we build Lego minifigures. But now let's get a more complex problem. Because these are the Lego bricks. 3 minifigures, just a few parts. And now we'll meet Bob. Bob works in a much, much larger company. He deals with thousands of products, thousands of customers, and thousands of ingredients he has to build from. And Bob is a planner, so his job is to meet all the work orders, all the purchase orders from customer, to have all the products that he needs. He has to plan the production and have all the ingredients to not lack any time in production. So this makes Bob really scared. How is he going to plan all this? And this is where artificial intelligence comes to help. And here is where actually machine learning platform comes to help. Because all the results from machine learning platform, after it's all done in backend, get presented in BI application. This is a Power BI application. And then Bob can look at this application, and those are the final products he has to produce. And then Bob can select a single item. He can see which item it is. And by looking at that, then he can take a look what are the quantities that he currently has on the stock, and how much is he selling of those items in some previous periods. And after that, Bob also takes a look at that forecast. This is our forecast for some periods, and what are we recommending to produce? Okay, Bob likes that. And then Bob also takes a look at these charts, and these charts show the historical sales of this product and what are our forecasts for the future. So he can actually verify the results he's getting from machine learning platform. And here is the stock, how his stock is changing in the history, and how is the stock going to be changing in the future with respect to expected sales. So this makes Bob happy. He's happier. He now knows what he has to produce. But also, Bob needs to look at the planning. What is he producing? When is he producing those items? So he can take on the next sheet, and on the next sheet he has all the work orders. The work orders are here, placed, and when they're going to start, when they're going to end. And here on the Gantt chart, he sees all the machines that he has and all the work orders that are being done on each and every machine. And also, he can select a single work order, and he can even take a look at Hoover over all the ingredients for this work order and see how the stock level will change in the future of this ingredient. So this is an ingredient. This is a raw material for this item, and he sees that he's using it here, he's consuming this item, and right here, he's ordering it from a vendor, and then he's consuming it again. So Bob knows when he's producing something, but he also wants to see how much he has to order of the raw materials from his vendors. And he has a third sheet, which is really similar to the first one, but those items are not products, those items are raw materials. And he can again take a look at the single raw material, he can see which material is this, and he can see the quantity that he has to order with respect to what is he going to sell, and when is he going to produce those products he's expected to sell. And now all of a sudden Bob is thinking, I'm happy. I know what I have to produce. I know when I'm going to produce that, and I know all the ingredients that I need. And voila, we made Bob happy. So when we made Bob happy, what are the benefits of all this? The first thing that comes to my mind is the automation. Because Bob's work is really hard if he's going to manually do all of this. So his productivity is definitely increased, while his manual work is decreased. And one other thing is that we increase the utilization of machines because we are optimizing all those plants. And I'm going to tell you a real story from one of our customers. They were thinking about buying a new machine because they couldn't meet all the orders they have. And they decided to try our planning module. And I will just tell you that instead of buying $1 million machine, they used our product to meet all the orders. And then, the next benefit is increased cash flow, because we're controlling the stock. By controlling the stock, we're lowering it by 25 to 65%. And by lowering it, we increase the cash flow. And also, from the financial standpoint, we increase profit. And profits are higher due to higher sales and lower cost. The first point is that by using forecasting, we much better anticipate the future sales, and we ensure the availability of the final product. I can tell you an example from my own life. A few months back, a furnace broke down, the heating machine broke down in my house, and I went to buy a new one, and they told me, like, you can get it, but it's going to take you 2 months to build it. So in the middle of winter, without heating, if I don't freeze to death, I'll get it in 2 months. So it's not good to always wait if you're a customer. If you're a customer, you want it right now. And also, by using forecasting and all the optimization, planning and scheduling purchase orders, we produce much less waste. And the next point is that we increase the service level. We increase the service level because by optimizing the plan, we know what we can see on the Gantt chart when it's producing what, and by doing that, there are much less delays in the production. And finally, there is much better possibility of controlling what is coming to a warehouse and when it's coming to a warehouse. This is happening because we're scheduling orders from our vendors on a frequency. Will it buy it daily? Will it buy it weekly, monthly, on 45 days or what? And we have much better control on when is what coming to our warehouse, and we create much more gems by doing that. And the fifth point is the verification through dashboard. We have seen Bob. What is he using? He's using those BI tools that we show the results in, and he can verify why are we producing those results? Why are we outputting those results? And the final point is that we provide the advantage in negotiations, for example, with a vendor, because we are knowing when are we going to order something, we can negotiate some bonuses or something like that to also lower the cost of buying raw items, raw ingredients. And to conclude, this is what we have been talking about. We have been talking about that what are the benefits? The automation of orders and planning. The second point is much better control and optimized stock. The third point is increased profit and cash flow. We increase the service level. And finally, we control the movement in the warehouse. And by doing that, we ensure that we have the right product at the right place at the right time across different industries, such as pharmaceutical industry, it can be a fashion industry, it can be food industry, and so on. And this is actually the end from me, but I wanted to show you one more thing. This photo right here is taken from one of our customers. They're actually using the planning model inside their factory, and right here on the screen is BI application in ClickSense that we developed for planning. This is a Gantt chart when it's something to be produced on these machines. So thank you for your attention, and thank you all the organizers for having me here. Great organization, and if you have questions, ask now or later. And one more thing, the team is coming tomorrow, so the whole team will be here tomorrow if you have any questions.
I think that we can give you a few minutes for your questions, if there are some. No? Oh, there is one? Okay, just a second for the mic, please. Nino, here you go. Thank you very much. I will put it here for you.
Hello. Working? Yeah.
Mm-hmm.
Thank you for the nice presentation. I would have just a question about how are you solving the planning problems? Maybe I missed it. What kind of algorithms or methods you're usually using?
For planning, it's genetic algorithm. It's evolutionary.
Yeah, you mentioned it. All right. But so mostly it's just planning. And what about for predicting demand and predicting stock?
For stock, we have many constraints for this ordering because many items have different constraints. Even vendors have different constraints. safety stock, which level we're going to have. So this is actually an algorithm that optimizes all the constraints we have. While for forecasting, machine learning models is not some machine learning models. We test many machine learning models with different features and different algorithms, and then we let the model choose the best one. And because, for example, we have a seasonal item uses a seasonal model. And the algorithm chooses the best one, and this provides us much better explainability why did the model forecast that. It's different models. It's many models, but it's not stacking. Then we are not stacking them, we're selecting the best one.
Are you using ensembles also, or case by case probably?
Are we using?
Ensemble models, like voting using just selecting one best model?
No. We're not using any sampling. We eliminate some kinds of things like outliers, out of stock period, some weird sales. This one contextual data, but we are not undersampling, oversampling. We use the data of a sale. It's a time series problem, so it's time series data.
Great, thank you very much.
Thank you for your question also.
So are there any more questions? Is there a question? No? Okay, thank you very much. Thank you, Nino, once again, and see you tomorrow, obviously.